Okay, so let's take a look at the example that describe the transformations of the function y equals 1/3 times x plus 1 quantity squared minus 4. All right, so we know a couple things here. Let's start with our h and k transformations, our horizontal and vertical transformations. Whenever we have anything inside the parentheses here, this is part of a horizontal transformation. Horizontal transformation, that's left to right. And when we have x plus 1, that is going to be a transformation to the left 1. Okay? Now we typically think of positive as moving to the right on a number line, but in this case the x plus 1 will make us move to the left 1. So it's the opposite sign in what we think of. Now, this is our k transformation. This is our vertical transformation. I liken vertical to using a hard K sound for the C here. For our vertical transformation, it's minus 4, which is down 4. And all of our horizontal and vertical transformations and everything comes from the parent function, which is y is equal to x squared, okay? Which starts out at 0, 0 is where the vertex is. Okay? At this point, the vertex for this function would be located at -1, -4. And that would be, again, transforming from the vertex of 0, 0, we would go to the left 1 and down 4. Now, the only other transformation we have to look at is this 1/3 here. This is our a value. When a is greater than 0, we know our parabola opens upwards. How have I spelled parabola? When we know a is less than 0, we have a reflection over the x-axis. In other words, it opens downward. When a is greater than 1, we have a vertical stretch. And by vertical stretch, the result is it becomes narrower. When a is between 0 and 1, we have a vertical compression. Which means it widens. So for this problem, we would say we have a vertical compression of 1/3. So for this problem, we'd have a vertical compression of 1/3. We'd have a horizontal transformation to the left 1, and we'd move this down 4. Go ahead and try 16, and notice what may or may not be in that problem. All right, so we're going to solve the following quadratic equation. And there's a number of ways I can solve this equation. I could solve it by factoring, all right? And I think factoring might be a good way to do this to begin with. Remember, solving is just finding our x-intercepts, or where y is equal to 0. That's what we're looking for. So we're going to use factoring because both terms share an x value. When I do that, my GCF here is x. So I take my x squared plus 8x, and I'm going to factor out an x from both terms. Now when I factor out, I'm dividing things out. I still have to retain that x. So I get x squared divided by x is x. 8x divided by x is 8. So I now have x times x plus 8 is equal to 0. If one of the factors is equal to 0, the whole equation goes to 0. So I can set x equal to 0 and x plus 8 equal to 0. To solve for x in the second equation, or the second factor I should say, I'm going to subtract 8 from both sides, and I get x is equal to -8. So my two answers could be x is equal to -8 or x is equal to 0. also given the ordered pairs of 0, 0, and negative 8, 0. That's one way I could solve it. I could use the quadratic formula here. I could try to complete the square. There's a number of methods, but I think for this one, factoring it is very simple because both terms have an x in it. However, I have one other way of solving this problem. Using Desmos, or the graphing calculator on your AZ merit test, I can come out here and enter in my equation, y equals x squared plus 8x. I can then touch anywhere along this graph. I'm going to get the keyboard out of the way. And you'll notice there are certain points. Down here, that's my vertex. I'm not interested in that. But we said the solution to a quadratic, or when we try to solve a quadratic equation, our solution are x-intercepts. Our x-intercepts are where we cross the x-axis. We cross the x-axis here, and we cross the x-axis here. Those are our x-intercepts. And the values for those are negative 8, 0, and 0, 0. The same values we came up here with our answers. So, by going to our graphing calculator, typing in our equation, and finding our x-intercepts by simply clicking on the x-intercepts themselves, we can then solve for our equation. All right, in this equation, or this problem, I'm asked to solve for the following quadratic. 2x squared minus 72 is equal to 0. I could use factoring as a process here. So the first thing I'm going to do is I'm going to factor out a GCF. Now you might be wondering, how do I know there's a GCF? Well, 2 and 72 are both even numbers, so I know my GCF would be 2. So I'm going to take my 2x squared minus 72 is equal to 0. Factor out the 2 from both sides here, and I could actually just divide both sides by 2. That's a result of factoring it out. And I will be left with, well, I'm going to factor it out first appropriately, then I'm going to divide by 2 later on. We'll show you why in potential problems later on. So I would have 2 times the quantity of x squared minus 36 is equal to 0. At this point, I can divide both sides by 2, and I have now x squared minus 36 is equal to 0. I still haven't lost any factors. I notice a couple things here. I notice this is subtraction. I notice x squared is a perfect square. 36 is a perfect square. I notice that I have no bx term. So that means I have a difference of squares. And this is easy to factor now. And what I'm going to simply do here is take the square root of x squared, that's equal to x. Take the square root of 36, that's equal to 6. And what I'm going to have now is my two factors of x plus 6 times x minus 6, and that's going to be equal to 0. I can then set both factors equal to 0. X plus 6 is equal to 0. X minus 6 is equal to 0. Solving for x, in one of the equations, I'm going to subtract 6 from both sides. X is equal to negative 6. That's also going to give me the x-intercept of 6, 0. So that would be one of my answers. The other answer, depending on what my problem's looking for, is I would add 6 to both sides. And I would get x is equal to 6. That's going to give me an x-intercept of 6, 0. My other option is simply plug this equation into Desmos. Y equals 2x squared minus 72. And find my x-intercepts. Those are going to be my solutions. And I see here I have negative 6, 0 and positive 6, 0. These are my x-intercepts. These are both the solutions I saw on my screen here, and I solved that by factoring. If I look at problem number 20, I would take a look at both your coefficient, your constant, the fact that you have that squared, and your subtraction as a hint as to how to solve 20. For 21, again, there's a number of ways I could solve it. I could try to complete the square, but that would be probably more work than I need to. I could use a quadratic formula, but probably the easiest way to do this is going to be simple, old-fashioned factoring. My leading coefficient is 1, so I can use my shortcut. So very quickly, a is equal to 1, b is equal to 5, c is equal to negative 6, ac is equal to negative 6. It means I need to multiply to negative 6 and add to 5. Well, there's only really one way I can multiply to negative 6 and add to 5. One of my terms has to be negative, the bigger of the two, or one of my factors has to be negative, the larger of the two factors has to be positive. So, negative 1 times 6 would be equal to negative 6. Negative 1 plus 6 is equal to 5. Since I know that my leading coefficient is 1, I know that my two factors are going to be negative 1 and 6, so I can factor this to be x minus 1 times x plus 6, and that's equal to 0. So what I'll do then is x minus 1 is equal to 0, x plus 6 is equal to 0. Add 1 to both sides, and I will see that x is equal to 1. Subtract 6 from both sides, x is also equal to negative 6. Okay, just really briefly here, I put both of my equations into Desmos. This was the original equation. The bottom one here is the factored equation. They both have the same tables, the same values in the tables. I look at my function here. I click on the x-intercepts. That works for both equations, or both functions, because they're the same thing. And I get negative 6, 0, and 1, 0, which were my answers back here. In the final example I'm going to do, we're supposed to solve the following quadratic. 6x squared minus x minus 2 is equal to 0. This one, I'm going to use the quadratic formula. My a value is equal to 6. My b value is equal to negative 1. My c value is equal to negative 2. My first job is to determine the discriminant. That's the value that goes under the radical sign. The discriminant is b squared minus 4 times a times c. Again, my discriminant then would be equal to b squared. Of course, I'm going to put the negative 1 in parentheses, then square it. Minus 4 times a times c, which is negative 2. Therefore, my discriminant is equal to 49. The quadratic formula is x is equal to minus b plus or minus the square root of my discriminant over 2a. And now I'm going to substitute in my value, so x will be equal to negative of negative b. Substitute in the negative 1 in parentheses, plus or minus the square root of 49, all over 2 times my value of a, which is 6. When I continue my calculations, I get 1 plus or minus the square root of 49, which is 7 over 12. This tells me I'm going to have two solutions. And those solutions are going to be x is equal to 1 plus 7 over 12, which is equal to 8 twelfths, which is also equal to 2/3. The other solution that I could have here, x is equal to 1 minus 7 over 12, which is equal to negative 6 over 12, which is equal to negative 1/2. Finally, as I've been doing, I can enter in the equation directly into Desmos, the graphing calculator on the AZ Merit Test, and I find out by clicking on my x-intercepts, those are my solutions. I get negative 0.50 and 0.667, which rounds to 2/3. All right, that should help you through the Unit 8 and 9 review for your AZ Merit Prep. Please get this packet done, work on this, and let's get this done by the end of today. Have a great weekend.